Alright, and now I'm going to talk about the section that I'm most afraid of myself, which is writing diagrams in LaTeX. So as you saw before in our notes, you are indeed able to write diagrams in LaTeX, such as this circuit diagram and that graph thing in CSM. I'll go over how you can do that with this tutorial. I don't know how long it's gonna be, but let's start with coding up circuit diagrams. So just to make it more specific, I'm going to write circuit underline fix and also have a file called circuit.txt so I can insert it from the main. So for LaTeX figures, my habit is that I will create one extra folder for figures so that I can deal with folders and text files instead of folders and text files and figure text files in one folder, in one greater folder. And that just helps me organize the information I have in front of my eyes, which often is very chaotic. Okay, let's start with circuits. And just a reminder, the diagram library that we are using is called TIX. And the circuit version is called circuit TIX. Alright, so let's talk about circuit diagrams. Where to draw circuit diagrams, there are a couple of basic things I'd like you to learn. Let's first start with trying to draw a voltage divider, which is a rather simpler circuit to deal with. So to write a voltage divider, let me teach you the basics of TIX while writing this circuit. Voltage divider. So once again, I would like to first input voltage divider so I can compile while editing this file. So to start a circuit diagram, we need to first invoke the environment called begin circuit TIX. Spelled as circuit and then TIX. How creative. There are also some optional parameters that we can use, for example scale, which I'm going to set as 0.8 for this one. We can also have American as an option so that we're using the 16-8 notations for resistors. If you want to draw a diagram, you have to say \draw. And then you can start from a coordinate. And you can draw lines or elements of a circuit between a coordinate and the other. So for example, I can say, \draw from 0, 0, which is a coordinate that we start with, to 0, 4, which is another coordinate that is 4 units higher than 0, 0. In this to part, I can then add a parameter to the to, which stands for what is going to connect these two things together. In this case, let me start with a basic that is a wire itself that we call short. Looks like I forgot to input circuit TIX in this package. I'm mentioning this every single video, I think. I did not count, but once again, these packages are supposed to be managed by your lectures, your classes file in CSM, so you do not have to deal with this. Your seniors have to deal with this. Well, eventually you will have to deal with this, so I'll talk about these at the end of the playlist as well. As mentioned before. Alright, but anyways, let's try to compile the file again and see what happens. Oh, okay, here's another thing. If you want to finish a draw section, so each \draw invokes one section of the circuit diagram. If you would like to end a section of draw, you have to type semicolon. This is just like how you need to end a line of your program using \semicolon. Okay, so for some reason it's not showing up. Let me try to say 4, 0 instead and see what happens. Okay, so now it shows up. As you can see, here is a wire. Maybe it did show up. I just did not center it. Maybe it did show up. Centering a circuit diagram is just a common habit, but I believe you'll also like to see your circuit diagrams centered instead of aligning to the left like this. Or at least that's what I believe. Okay. Let's try again a vertical wire. If not, we always have more chances to do vertical wire. So you do see that the vertical wire shows up. Maybe it was just hidden in the edge here and I didn't see it. As you can see, I am legally blind today. Okay, so while we can go from coordinate to coordinate, here's a recent hack that I found, which is a bit easier to deal with, is that you use ++, which allows you to then use a coordinate pair to notate how many units you would like to traverse from the current point. For example, if I want to go up 4 points, I can just write ++0, 4. It'll do the same thing. If I would like to go horizontal 1, then I can write 1, 4 instead. As you can see, this is a horizontal. There's a diagonal wire that goes 1 unit horizontal and 4 unit vertical. You can pick up a ruler from your room and try to measure this, but I wouldn't do that. Well, besides short, there's also a thing that we can write. There's also another thing we can put here, which are circuit elements. For example, a voltage source, which is noted by the capital letter V. Then I can write L equals, which means label equals. And I can write the label of the voltage source here. Let's see what happens from this. So as you can see, I have written a voltage source here. To invert the direction of the voltage source, you can write comma invert. To add a ground node to this, you can also write \node ground in front of 0, 0. Which should actually take one more curly bracket if I'm not wrong. So at times like this, you can stop compilation and recompile. It might prove a bit easier. And another mistake from me, this actually does not need a backslash. That's another thing that that's another thing that we're going to go over in the next few minutes. I am very sorry. Okay, so as you can see, we have added a ground node at 0, 0. Notably, we can actually put the node in front of after the coordinate before the 2, and that should be the correct way to do this instead. As you can see here. Okay, so after going up 4 checks to draw a voltage divider, I'll also like to go left, and I'll also need to go through a resistor for that. So I can write 2 and R stands for resistor. And I can write L equals to label my resistor. I can type I don't need to type invert here because resistors don't have directions. So for example, if I would like my resistor to go through a space of 1 horizontal unit, I can do this. Once again, you need to put a semicolon here. And you can see that 1 unit of horizontal space is not quite enough, so I use 2 instead. As you can see, this is about barely enough. And what I'm going to do then is, well, we already have a semicolon here. We don't really need another one here. Okay, so I will then have to draw out another resistor, but what I can do is first give it a few more space to work with, so that I can draw the next resistor here with a bit more space. And last but not least, I can use another wire to go down to my original height, which would be going down 4 units. And I can put another ground node here. Okay, and we already have a semicolon here, so no worries. Okay, so as you can see, this is how we can type out a circuit diagram. Here is an interesting thing that I would like you to know, which is that you can also annotate the circuit. First of all, let's talk about how to annotate it in passive sign convention. If you would like to annotate the voltage of a resistor, you can say small v and then equals. And then, for example, you might want to say the voltage of R1 here, so you can say VR. So this is the passive sign convention, as you can see. Usually my habit is just to have the plus negative sign on from this small v and just not have any text in between, so I can work with an empty label. You can also see that the space is a bit crowded, so what I like to do is to expand the space from 2 to 3. You see, the good thing about using this coordinate, relative coordinate instead of absolute coordinate, is that you only have to care about the distance between your elements, and you don't have to retune the position of your element every time you change some other difference. So this is actually quite convenient compared to an absolute coordinate system. As you can see, it's rather easy to just adjust the size of a component than have to adjust the distances between their centers. This is a bit inefficient. Okay, so now we have the passive sign convention. We also need an arrow mark for the current, and what you can do with it is you can say I equal, and then maybe you can put the current name you have here. For simplicity, I'll just call the current flowing through resistor 1 to be I1, and here I2. Now, usually it's automatically right above the arrow, but you can also use extra parameters to make it go below. As you can see, using the underscore makes it go below, and using the caret here, or the caret here, makes it go above. Similar for the label, you can use underscore to make it go below the wire. Saves a bit of vertical space, but not too much difference, so I'll reduce it to its original. Okay. So this is how you can write and annotate a circuit in passive sign convention. But there's another thing I'd like to show you, which is that you can also annotate the wires themselves using nodes. Here we see a node of ground, with ground being the optional parameter. We can also use node of other shapes, such as circle, which is just called circ, and then I'm going to fill it with a black color so that it's easy to see. And then I can also put a label here called, for example, node X. And I'll see a dot with label VX on it. Meanwhile, nodes should also have empty label text, which is why I'm putting a curly bracket here. So this should cancel out the LaTeX error I have here, which works out. So you can also adjust your label to be at different positions. For example, you can make it below your current node, which would just take an extra below column here in your text. Okay, so this is the basics of drawing a resistor circuit in circuit TIX. Now let me show you how to draw a bit more circuits. For example, maybe something like a capacitor circuit. So I'm just going to copy this entire circuit and then change a few elements to let you see the differences once I switch up the notations in my circuit TIX. Need to change the name here. Okay, so I'm going to change all of the resistors into capacitor, and it's very easy to do that. You just say C instead of R. I'm also going to change my voltage source into a current source, which is just using I instead of V. And yeah, we do need to change our label as well. Oops, almost accidentally saved this. Accidentally saved this again. Let's use Ctrl Enter instead. Okay, and current source should not be inverted in this case, so let's adjust that a little. Okay, that works out. And last but not least, you can also use the I equal and V equal nodes on your current source, as well as your voltage source. I'm just going to demonstrate this with the current source. As you can see here. Well, actually, the passive sign notation here is slightly sus. I would actually just not include that instead, or include that and make the solution a bit more complicated. Alright, so that's how I'm currently working with circuit TIX. So here are the here I have already told you some basic components. Well, there's another monster to deal with, which is called op-amp, and we'll also go over that a little. In this case, I would like to go over an inverting amplifier. So before that, let me try to recall what an inverting amplifier looks like via the power of Google Doc. Let me show you what an inverting amplifier looks like, just in case you have forgotten everything in 16A, just like what people usually think they do. Well, let's just search up Google Images and hope nothing cursed comes out. This one should work. Okay, so this is what an inverting amplifier looks like. And we're going to try to create this circuit in LaTeX. So first of all, I still need to start my circuit diagram with begin circuit text, because this is just how we draw circuits. Let's also add an extra line at the end of the document, because I got roasted about it. Once again, you can scale your op-amp. This time I will not scale, and I'll only use the American option. And we do have to draw. 0, 0 is our starting point. So here's the interesting thing. There's also a node not only for ground and circle, but also for op-amp. So I'm going to name this node capital AMP. So whenever you mention the name capital AMP, it will refer back to this node. And every node needs a label text, which is marked by the curly bracket. Okay, now I am going to go onto another path, by which I mean I'm going to start a new wire from another point. But to do that, what you can do is to simply start another path within the draw environment, and you don't have to write a semicolon to start another path. Or you can also have another \draw environment here, and just have each path have one draw environment. You'll see what I mean later, but generally I prefer writing circuits like this. So I'm going to start from the negative part of the amp. Actually, I should show you what an op-amp node would look like now, which I forgot to input the circuit diagram for. I should show you what op-amp node looks like before I move on, so that it's easier to explain how this entire LaTeX thing should work out. Okay, thank you. So this is what an op-amp node looks like. And let's go back to an inverting amplifier here. So you see we do need to do something from the negative side of the op-amp, which we're going to do now. But as you can see, we have started from 0, 0, which is around the center here. So it is relatively difficult for me to have to complete this entire circuit with just one continuing series of elements. So for example, in the voltage divider here, we used a series of elements without switching start. Our endpoint at one wire is immediately the start point of another wire. But in the op-amp diagram, I'm going to have to not do that, and I'm going to have to have new start points for some of the wires, so that I can draw the diagram a bit more efficiently and a bit more readably in terms of LaTeX. So that's why I'm going to start from a new point instead, by simply typing a new coordinate and simply typing a new to command. So in this case, I'm going to first use a wire to go up one element above, which will be around here. So one unit above, which means plus 0, 1. And then what I can do for convenience now is to note a coordinate at this point I'm currently at. And once again, the parentheses here is trying to help me name the coordinate so that I can reference it later. Okay, and then I'm going to have another to command directly from this coordinate top left, which is one element above the origin, one element above the negative node, sorry. So I'm going to have, I'm going to have a resistor here called RF. So label of this is equal to RF. I am not going to write any passive sign convention yet. Okay, so here are some choices for us to draw out this. Either we can draw out the two vertical turns here, or we can use a shorthand notation to help us, which is first typing in a coordinate name, and then say horizontal and then vertical, and then amp.out. So this allows us to now have our F relatively easily written out. And last but not least, what I can do is connect the rest of the circuit to the out node. which, as you can see, we have now built a negative feedback loop. I can then go on to write this part of the circuit via an open circuit, which can be noted by the -O. That means you are having an open circuit at the ending part of your of your wire. And maybe I would like to go right by 1 unit, so I'll write ++1, 0. As you can see, it's relatively convenient to just edit and compile at the same time to see whether you have the things right. Okay. And then I'm going to have an open circuit. And I'm going to have this 2 units below what I currently have. These are all new commands, so just learn while watching the video and reference back to this video whenever you like to. I am going to write V out for representing the output voltage of the amplifier. Okay, so as you can see, we have this. And last but not least, we can just use another 2 short to somewhere lower. And just add a ground node here. That works out. We can go a little less. Negative 0.1 BF maybe. Okay, that works out. And then now we just have to deal with the rest of the circuit that we forgot to draw here. So now's another good time to switch starting points. I'm going to start from the negative node of the op amp again, but this time I'm going to write a resistor called R of in, and I'm going to move rightward by 1, or leftward by 1, so I should do this. And then afterwards I can just mark an end here, which this should be connected to an input voltage. So what I'm going to do is, let me organize the code. Okay, so what I'm going to do is then write out another voltage source and label it as V in, which is about 1 unit below what I'm currently at. As you can see, the space is a bit too small, so let's do a little more. Okay, doesn't look too bad. And the label seems to be clashing with each other, so I'm going to change the direction of the label a little. And last but not least, I'm going to add a ground node here to give it a good ending. I'm also going to have to add a reference voltage source from the positive part, from the positive node of the op amp. So also we'll do that by doing something very similar to here. Now you see another good thing about relative coordinating system is that you don't exactly have to know where m dot plus is, and you also don't have to calculate the exact coordinate where you wish your elements to be ending up with, and this is relatively easier to deal with. Okay, let's just compile the file and see what happens. Okay, change the direction of the V in a bit. Okay, so this is an inverting amplifier, as you can see here, using the op amp node. Now that we have went through the basics of circuits, let's also talk about graphs for a bit, which I am going to use a new document for. And I'm also going to have to input this into my main document, so let me edit that as well while I'm at it. Should be called graphs. You see, this is where autocorrect comes in use, because I do not know what's the difference between graph and graphs. This is another subsection, so we can just start with subsection graphs. Okay, let's see if it properly embedded. It did. Nice. Okay. It would actually be helpful if I put the code right below op amp invert. So I'm going to use a verbatim environment to enclose my code. There are different ways to put your code here. For example, 6.1a I think uses LST listing, which is another environment. Verbatim is also a good environment for listing your code. In this case, there's just a slight difference of property, but verbatim is what I'm currently going with for putting code. Okay, so graphs. Now, graphs are CS70 topics, but it also does have a thing called Markov Chain, which I'd like to talk about. Because Markov chains are not only represented as graph applications in CS70, but also represented as PageRank algorithm in EEC16a. Okay, so let me create a new file called markov.tech and input this into our current document. Nice. Okay, so it's very similar. How you draw circuits is very similar to how you draw graphs. Instead of using circuit tigs, though, you'll need to use another environment called text picture. Okay, so text picture comes with a few optional parameters, which I'm going to go through now. First of all, I'll use the -LaTeX, so I have automatic arrow marks. I also like to use auto to auto label. Let me write that in the auto label position of arrow marks. To automate the label position of arrow marks, and this is for automatic arrow mark on internode paths, which are the arrow marks you see between the different circles in the Markov chain. I also have to set up the node distance. For now, I'll set it as 4 centimeters, and I'll just adjust later. I also like my edges to be semi-thick, and I'll also like my style of the node, which you can dictate as this, to be drawn circles. Okay, so these are the parameters, and this node name is now going to be a variable I can reference when I'm trying to draw nodes of a Markov chain, or the circles of a Markov chain. For example, I can draw a node that has a name of A and is called Among Us. That's the first word that came into my mind when someone asks what word starts with A. I am very sorry. Okay, while I have drawn this node, I also should have attached a semicolon to it, and I'll also draw a few more nodes to show a Markov chain. Whatever starts with B, very clear. And last but not least, I also have another node called C, which California would be a good word for, I guess. So as you can see, I now have 3 nodes written here, but I have not adjusted their positioning yet, so they're all overlapping together. The way I can adjust the position of nodes would either be using coordinates. For example, I can perhaps use coordinates to locate my nodes, which I cannot, sorry, I'm wrong about that. But I can do positioning using keywords that make my node have a relative position to other nodes. For example, if I like my node B to be below and left of A, I can write such that my program helps me put my node B be below and left of node A. Okay, and I can also do the same thing for node C, which I'll use below right off instead. Okay, and the at way can also be used not after the curly bracket, but in front of the curly bracket, I believe. For example, if I like to locate the node A to somewhere else, I can write this so that I can change the coordinate of node A to 2 units horizontal, 2 units right to what I currently have. Meanwhile, let me change the names correctly so that the entire graph moves with it. You can see it's the positioning is a bit locked. Okay, so while we're at it, let's also talk about how to draw the edges. So if you like to draw edges for a Markov chain or the arrow marks between these different circles, what you can do is use the command \path, But we'll talk about a more general way to draw lines later. For now, let's use \path for ease. So the general template of a path in Markov chain is as shown here. I'm going to explain this line here. So when I have such a, sorry about this, I forgot to type it correctly again. Okay. So when I have this line, what it does is, first of all, it constructs an edge starting at node A and ending at node A. So starting at node A, ending at node A. Edge is an option. Loop above is what the path will, loop above is the general itinerary that the path will follow. In this case, I am trying to redirect all of the resources from this A circle into itself again. So I would like to have a loop. And then node curly bracket 1 here just means we're constructing a node with curly bracket 1 being its label. So we can follow the same logic and write out self loops for node B and C as well, which I'll change the loop direction slightly to respectively left and right. And maybe I'll not have all resources in Berkeley to redirect to itself. I'll maybe just have 0.5 of Berkeley redirect to itself, and the same for California. Okay, hopefully my cat is not blocking this. It probably is not. Okay. Now, I would also like to have edges between different nodes, and the way I can do that is to copy this exact syntax and just change the start over the end, depending on where your arrow wants to start at. And then I also have to change the option here in edge. Let's see what happens if I leave it empty first. So if I leave it empty, it becomes a straight edge. Sometimes, however, I'll also like to have edges from C to A instead of from A to C. So a good solution for that would be I can write an extra parameter or an extra option in edge called bend, so that I can bend each of the edge into a different direction, like this. Oops, I should have both of them be bent right. So as you can see, the edges are each bent to the right side, depending on its start point and end point's relative position. You can also adjust the degree by which your edge bends. For example, I can say bend right equals 20, and you will see that the edge from A to C will have a slight change in how much it's bent. Unless they fix that syntax. In this case, maybe something is going wrong, and I will not do that then. Oh wait, okay, so as you see, the A to C edge does get bent 20. For some reason, let's just keep running. Okay, now it's normal. So as you can see, this is how we can complete a Markov chain graph. So the way in which you can draw CSM graphs is very similar to how a Markov chain can be drawn. Let me show you that really quickly. With a new file here for graphs. Now this is not so good of a naming sense. If you are writing content, you'll probably like to name this a bit more specifically, but for now, I am going with the simplest choice I have on my arsenal because the time of the tutorial is slightly running dangerously. Once again, to draw graphs that are not circuits, you can use text picture. And here, let me show you how to draw a disconnected graph. So first of all, we would like to use optional parameters as talked about before. Here, I'll just use the node style so that I can have nodes. And I'll also change my node style a bit into bullet point style, which means it looks something like this. So these circles will now be bullet points instead of these big circles. Let me also put this in a slightly more elegant way. Okay, so once again, draw nodes first. I will showcase you how to draw nodes in with coordinates in this graph instead, because the last graph did not work well with that coordinate choice. So let me show you how to, so once again, to draw a node at a specific coordinate, you can say node and then name and then at coordinate and then curly bracket label. Let me show you how this eventually works out. I would probably like to start from 0, 0 as well, so let's do that. And then 1, 0 for the second node, and 2, 0 for the third node. Oops, did not change that. Okay, so let's see how it compiles out. Right below. As you can see, the circles are a bit too big. Let's delete the intercept because I don't think we need that. We actually do. Hold on. Let me try to adjust this slightly. In this case, we can also try to adjust this so that it's 0.1 instead. Or maybe we can use circ instead. Okay, that's the right keyword. Using circ gives you a bullet point. Okay, so now you can see the nodes with labels, but the labels are a bit too close to the dot. So I also like to change that using optional parameters, which can put around here. I'll just say label is equal to something. I'm going to set the label at the top of the vertex. And I'll call the label A, and I'll just make the original label be erased. So in that case, you can see I have relocated my label from up to below. Oh, sorry, from right to upwards. I'll do the same thing with other nodes here. Okay, and I'll create a few more nodes to show a larger graph with their y coordinate being lower than what I currently have, and their labels also changed a little. With their direction of the label also changed a little, so I can draw edges between the top and the bottom nodes later. So as you can see, this is a graph with 6 vertices so far, and now I'm going to start drawing edges. So, as you probably know, graphs can either be undirected or directed. If you want an undirected graph, what you can do is directly draw an edge between the nodes you designate. So for example, if I like to draw an edge between A and F that is undirected, which means it does not have arrow mark, I can directly do this and use the generic draw method to draw an edge here. Now you can also do the same for other vertices, which I'm going to do here. And now we have a bipartite graph. Why is that word so hard to speak? Bipartite graph. You can also write a connected graph by adding more edges, and you can also write a directed graph by changing some parameters here. So the way you can add arrow mark to your edges is using the stealth option. So the stealth option allows you to draw an arrow mark at the direction of your choice. If you like to draw from your start point to if you like to draw your edge from start point to end point, such that your arrow is pointing towards your end point, put the stealth keyword at the side of your end point. So for example, if I do stealth dash instead of what I have before, the arrow mark should be pointing towards A. I can do this to make my graph directed. Okay, the arrow marks are a little bit difficult to see, and there are also options for adjusting so, but I will leave that as an exercise for the reader. So this is the general guide on how you can draw graphs and circuit diagrams in text picture using text picture and circuit ticks.